Hi, hello, welcome back to VSM Math tutorial. Dear students, in the last class, we had discussed about theoretical part of binomial distribution as well as Poisson distribution. Theoretical part means we have done the proof of mean and variance of the binomial distribution as well Poisson distribution. In this class, we will study some problems on binomial distribution. In the next video, I'll do some more problems on Poisson distribution. So let me start with this problem. Before that, if anybody is not subscribed my channel, kindly subscribe my channel and press like button, and also share this video with needy people. Means many students, they're searching probability videos. If you know any one of them, please help them. Okay, so kindly press bell button also for upcoming videos. So now we'll start with this problem. This problem is purely based on binomial distribution. So what it says, problem statement: when a coin is tossed 4 times, find the probability of getting exactly one head, at most 3 heads, and at least 2 heads. Okay, so first we have to write the given data from the problem statement. What they have given: probability of getting head, that is P of H. What is P of H here? 1 by 2, because when we toss a coin, only two possibility: either the coin will turn out head or the coin will turn out tail. So getting a head is 50%, getting a tail is also 50%. So that is the reason probability of turning head or getting head is 1 by 2. When we know 1 by 2, we can easily write Q value also. Okay, so this is 0.5. How to write Q value? Q value we know, that is 1 minus P, because P plus Q is 1. In probability we know that. So Q value is what happens? 1 minus 0.5, that is 0.5. So Q value is also 0.5. Q value is also 0.5. Now the number of trials they have given. What is that? The coin is tossed 4 times. Therefore n equal to what? 4. N equal to 4. Now we know that when the binomial distribution is used, when the trials are large. Okay, here the probability of x successes. Okay, we'll write that the probability of x successes out of n trials we know, that is binomial distribution. Out of n trials is what? P of x equal to NCX P power x Q power n minus x. Okay, so if you write this in the exam, you will get 1 mark for this, 1 mark or half marks for the given data representation. Now we'll go to the first problem. What it says: at most 3 heads. At most 3 head means maximum 3 heads. Okay, this is second question. First we'll go with this one, exactly one head. Exactly one head means only one head. Okay, so that is first one, exactly one head. Exactly one head. So what it says, that is exactly one head means what? Probability of getting one head is nothing but what? X value should be 1, because we clearly told here x successes. So probability of getting head is a success here. So probability of getting only one head is nothing but x equal to 1. So this x equal to 1 we have to substitute in the given binomial distribution. Rest of the things we know here. P we know, Q we know, N also we know. So what happens if I substitute NCX 4C1, because n value is 4, x value is 1. 4C1 p power x, p is what? 0.5, x is 1, q power x 0.5, n is what? N is 4. Okay, 4 minus x is what? 1. 4 minus 1 means what? 3. So what happens if I solve this? We will get 0.25. So probability of getting exactly one head when we toss a coin 4 times is 0.25. 0.25. Okay, so this we can obtain by normal probability also, but if we operate binomial distribution, it is very convenient. No confusions, nothing's here. Okay, now I'll take the second part. What does the second part says here? At most 3 heads, and third question is at least 2 heads. At most 3 heads, at least 2 heads. We'll go one by one. So I'll consider the second sub question, that is, what is that? At most 3 heads. So at most 3 heads means maximum 3 heads. At most 3 heads means maximum 3 heads. So what we can write? At most 3 heads means what are the possible things? How we can write? So probability of at most 3 heads equals to at most 3 heads. How we will write? The first possibility, no head. When we toss a coin 4 times, no head, that is x equal to 0. Second possibility, only one head, x equal to 1. Third possibility, 2 heads. And third possibility, what? 3 heads. They are asking us to find out at most 3 heads. So these are all possible things. So what happens if I substitute everything in the formula? 4c0, because x equal to 0, if I substitute here, n we know 4, 4c0, p we know, q we know, everything we know, substitute. So what happens? That is 0.5 power 0, because p power x, p is 0.5, x is 0. 0.5 power 4, because n minus x, n is 4, x is 0, for p equal to 0. Similarly, we'll write second one, x equal to 1. So what happens? It is 4c1, 0.5 whole power 1, 0.5 whole cube. Then p of x equal to 2, what happens? 4c2, 0.5 whole square, 0.5 whole square. See, I am not doing any kind of calculations here. I am just substituting n value, x value, p value, q value in p of x as per the x values here. Okay. So the last one is what? P of x equal to 3. If I substitute that, what happens? That is 4c3, 0.5 whole cube. So what happens if I substitute all these values? You can use scientific calculator also for simplification. I hope everyone know how to simplify this using scientific calculator. So if I simplify this, I am getting 0.9375. So this is the answer for probability of getting at most 3 heads. Okay, so here the very important thing in probability is writing the data in a proper way. So that if we do properly, then rest of the simplification is very simple. The last one is what? The last sub question in this part is at least 2 heads. At least 2 heads means minimum 2 heads, but it may be more than 2 heads also. Possible things are there. So I'll just take third. What is that? Third sub question answer. P of at least 2 heads. P of at least 2 heads. So how we will write? At least 2 heads means it may be more than 2 heads also. Okay. So at least 2 heads. There are 2 possibility. After 2 we can find out P of x equal to 2, x equal to 3, x equal to 4. Or probability of success and probability of failure we know. P plus q equal to 1. Or probability of failure if we want. How we will write? 1 minus P of 1 minus P. Because P is probability of success. In that logic, if I do 1 minus probability of x equal to 0, probability of x equal to 1, if I do, I'll get the probability of at least 2 heads. See, the logic is simple. This you can also write like this, or P of x equal to 2, P of x equal to 3 plus P of x equal to 4. Instead of simplifying all these, I can easily write like this also. Okay, so probability of, see how we will write, P plus Q equal to 1, right? If I want P of, Q 1 minus P. P is what? Probability of success. So at least 2 heads means minimum 2 heads, but more than 2 heads is possible. Minimum 2 heads means if we find out before that, then if we subtract 1 from that, we will get remaining answer. Very simple. So what happens, this is 1 minus x equal to 0 if I substitute in P of x in the formula, binomial theorem. So what happens, that is 0.5 whole power 4 plus 4c1 0.5 whole cube. So if we simplify as usual using calculator, so answer will be 0.6875. So this is all about a very simple problem in binomial distribution. Okay, so kindly follow this. If anybody having any kind of doubts, you can put in the comment box. Very simple problem, basic problem I have taken here. So then I'll move on to the next problem based on binomial distribution. Now we can see one more problem I'm going to take here. It is one of the applications problem, real life problem. What it says, the number of telephone lines busy at an instant of time is a binomial variate with probability 0.1 that a line is busy. Okay, if 10 lines are chosen at random, what is the probability that no line is busy, all lines are busy, and at least one line is busy? And fourth question, at most 2 lines are busy. See, the statement looks like big one, but if we read it properly, if we analyze it properly, then the solution part of this problem is very simple. Okay, so in probability, many times I told, analyzing the problem and writing the proper data is very important. So here it is clearly mentioned binomial variate, so the problem is related to binomial distribution. Now how to solve this? We will take telephone lines busy is there, no? So it is the problem of telephone lines busy. Let what we will do, x denote the number of telephone lines busy. Okay, I'll consider, let x denotes the small x denote the number of telephone lines busy. Okay, now from the given data, what are the from the given problem, what are the data they have given, we'll consider. What is that? The number of telephone lines busy at an instant of time is a binomial variate with probability 0.1. So P is given. Okay, so small p, probability they have given 0.1. From P I can easily find out Q, because Q is 1 minus P, 1 minus 0.1. So how much it is? 0.9. So Q is 0.9. And N, how to find out N? They have given, if 10 lines are chosen at random, what is the probability? So we are going to find out probability for this 10 lines. That is the reason we will consider N equal to 10. N equal to 10. So now we have binomial distribution, that is P of x. What is that P of x? NCx, P power x, Q power n minus x. So what happens if I substitute all the values? 10cx, because n is 10, x we don't know, 10cx, P is 0.1, 0.1 power x, Q is 0.9, 0.9 power n minus x, means 10 minus x. See, in the exam, if we write the formula, given data and one step substitution, easily you can score 1.5 or 2 marks. Okay, so now we'll go for the problems. What is the first problem? No line is busy. out of 10 lines, no line is busy. No line is busy means what? X equal to 0. Okay. So probability that no lines busy. No line, because only one line is there. No line is busy. So no line is busy means what? That is X equal to 0, because what we taken, X indicate the number of telephone lines busy. No lines busy means what? X equal to 0. Now what happens if I substitute? Therefore P of 0, because X equal to 0. So if I write this, what happens? It is NC0. N means what? 10. 10C0, 0.1 whole power 0, 0.9 whole power 10 minus 0 is 10. So what happens? It becomes 0.9 whole power 10. So if I simplify again using scientific calculator, answer is 0.3487. So when no lines are busy, we have to assume, we have to consider X equal to 0, because we clearly written here X indicates what? Number of telephone lines busy. No telephone lines busy means that X equal to 0. Now I'll write second one. What second? Says probability of all lines are busy. Probability of all lines are busy means what? Probability that all lines are busy. 10 lines are there. Out of 10, all lines are busy means all 10 are busy. That means that is X equal to what? 10. X equal to 10. So what happens? Therefore P of 10 equal to N is what? 10. 10C 10, 0.1 power 10, 0.9 whole power 10 minus 10. So what happens? It is, if I simplify this, this become 1, this become 10 minus 10 0, anything power 0 is 1, 0.1 power 10. Answer is 0.1 power 10 for all lines busy. Then I will go for the third sub question in this problem. What is that third sub question? Probability that at least one line is busy. Probability that at least one line is busy. Probability that at least one line is busy. See, at least one line is busy means what? That is X is greater than or equal to 1. It may be 2 lines are busy, 3 lines are busy, 4 lines are busy, 5 lines are busy. Okay, total 10 lines are there. So at least one means what? Minimum 1, but it may be more than 1. Now if I consider X is greater than or equal to 1 means the possible things are what? X equal to 1, X equal to 2, X equal to 3, X equal to 4, X equal to 5, X equal to 6, X equal to 7, X equal to 8, X equal to 9. That is probability of X is greater than or equal to 1. How we will write? P of 1 plus P of 2 plus P of 3 dot 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 P of 10. It becomes very tedious, very lengthy process. So then in that case we have to use reverse, that is P plus Q equal to 1 or Q equal to 1 minus P, this formula. Okay, instead of finding all the values, if we go with the reverse way, how to go with reverse way? Probability of X is greater than or equal to 1, how to write? 1 minus probability of no line is busy. At least one line busy means minimum 1 out of 10. Okay, so how to find out? 1 minus no lines are busy. So probability of no line busy. Okay, no line is busy. Very simple it is. If we do like this, I have to substitute every data in the P of X binomial formula. It becomes very tedious, very lengthy process. So to avoid that, I am using alternate form. So it is very simple. So what happens? It is 1 minus P of 0. 1 minus P of 0, because no lines are busy means 0. P of 0 we already calculated here, 0.3487. Okay, that you substitute. 1 minus 0.3487. So what happens, it is 0.6513. 0.6513. So fourth one, I'll give as assignment for work for you people. It is similar to the previous one. Here probability that at least one line is busy. Fourth one is what? At most two lines are busy. Okay. Probability that at most two lines are busy. At most two lines are busy means maximum two lines. Maximum two lines. So maximum two lines means what? That is x equal to 0, x equal to 1, x equal to 2. Maximum 2. Okay. So that what happens? P of 0 plus P of 1 plus P of 2. So if we substitute and simplify, you will get 0.9298. This is your assignment or homework. Okay. Kindly, what you are supposed to do, P of 0 means substitute x equal to 0 in binomial distribution, P of 1 x equal to 1 in binomial distribution, P of 2 x equal to 2 in the binomial distribution. Now we have done in the previous problems. Okay. So this is one more very important question usually asked in the standard examinations like VTU, some other universities. So that is the reason I solved this. Kindly check, any doubts are there, again put in the comment box. Now I'll take last problem, one more problem, very important problem based on binomial distribution. So then in the next video we'll solve some problems on Poisson distribution. Okay. So next I'll move on to the next problem. Now this problem, if you see, very interesting problem. See, the probability concept is like this only. When we realize this concept, when we understand this concept properly, then it is very interesting, because we can apply this probability concept in daily life problems also. Okay. So one such problem I am considering here. What it says: in 800 families with 5 children each, how many families would be expected to have, okay, 3 boys, 5 girls, either 2 or 3 boys? See how beautiful question is. This is like one small village is there. In that village 800 families are there. 800 families contain, each family may have 5 children each. The question is how many, we are going to find out the probability that how many families would be expected to have 3 boys, out of 5 3 boys and 2 girls. All 5 children are 5 girls, or 2 girls to 3 boys, 3 boys 2 girls, like that we have to find out the data. Okay. So very interesting problem. I'll just move on to the solution part. What it says, see, probability of having a boy is what? 50%. That is why, probability either the birth kid is boy or girl. Very rare case it is other. So usually 90% boy or 90% girl. That is 50% of the possibility of getting boy and 50% of the possibility of getting girl. So I'll write that. So P, what does that P indicates? Probability of having boy kid. Okay, probability of having a boy. How much it is? 1/2. Then Q, probability of having girl. Probability of having girl is also 1/2. Now X denotes the number of boys in the family. Let X denote the number of boys in the family. X denote the number of boys in the family. So what it says? P of X equal to NCX P power X Q power N minus X. This is standard binomial distribution. Now what is N here? We are finding for how many kids? 5 children each. So therefore n equal to what? 5. N equal to 5. So if I substitute everything, now what happens? P of x equal to 5cx. Q is 1 by 2, P is 1 by 2. So therefore 1 by 2 whole power x, 1 by 2 whole power 5 minus x. So what happens if I simplify it further? So it becomes 1 by 2 power 5 5cx, 1 by 2 power 5 5cx. So or this you can also be written as 5cx by 32. How we have written this? 1 by 2 power 5, because you can split the powers here. If you split the powers, what happens? 1 by 2 whole power 5 into 1 by 2 whole power minus x. So 1 by 2 whole power minus x, 1 by 2 whole power plus x cancel, that is 1 by 2 whole power 0, 1 by 2 whole power 0 is what? 1. So we left with what? 1 by 2 whole power 5. That will be written like this, 1 by 2 power 5, and this 5cx as it is. 1 by 2 power 5 means 32. See, if we simplify this term in the beginning itself, further calculations are simple, or else we have to struggle in the, if we carry this term as it is, further calculation will be like time taking work. Okay, that is the reason we simplified in the beginning itself. Now what we have to find? We have to find, this is for one family, I mean X family. Like how many families are there? 800 families are there. In the question they have mentioned 800 families with 5 children. Okay, this we have to find out for what? 800 families. Therefore, since we have to find for 800 families, so how we will write? 800 into P of x. 800 into P of x, what happens? 800 into P of x value we have here, that is 5cx power divided by 32. So this is what our function now. This is what our function. Now we'll go one by one. Questions. What is the first question? The probability of getting 3 boys. The first question is 3 boys. Okay. So that is, let it be, you call this whole function as some g of x, other function. Okay. Now probability of all families expected to have 3 boys, that is g of 3 we have to find out. G of 3 we have to find out. So what it says? G of 3 equal to 800 5c3 divided by 32. 5c3 divided by 32. So what happens it is, if we simplify this, we will get answer as 250. This you can use calculator and you can simplify. I am not using calculator here. This you can use 800 by 32 simplify. 5c3 we directly get it from the calculator. Okay, so if you simplify that, you will get the answer as 250. So the expected number of families with 3 boys is what? 250. Therefore expected number of families with 3 boys is 250. Now second one is what? 5 girls. 5 girls. 5 girls means what? Here we have taken x denote the number of boys. Number of boys means out of 5, all 5 are girls means what? Number of boys are 0. That is g of 0 means 5 girls. Okay, the family is expected to have 5 girls. So what happens? G of 0 equal to 800 divided by 32 into 5c0. So 5c0 is 1. So 800 by 32, if we simplify, that is 25. Therefore, expected number of families with 5 girls is 25. Expected number of families. Expected number of families with 5 girls is 25. And the last question is what? Either 2 or 3 boys. Either 2 or 3 boys. Third question is what? Either 2 or 3 boys. Both are possible. Both are possible. Either 2 or 3 means that is g of 2 plus g of 3 we have to find out. So what happens at a g of 2 plus g of 3 means what? That is 800 by 32 5c2, then 800 by 32 5c3. So if we simplify this, we will get 500. We will get, because this is 25, okay, 25 into 5c2, 25 into 5c2, it becomes 55c2. 55c2 means what? 5c2 value, we may get 10. So 10 into 50. So 50 into 10 we will get, that is 500. Therefore, expected number of families, expected number of families, expected number of families with 2 or 3 boys is 500. Okay, so that's all for problems on binomial distribution. Okay, so kindly go through all the problems from this video. If anybody having any kind of doubts or needed clarifications, kindly put in the comment box. Once again, my humble request to all my viewers is, if you are not subscribed yet, kindly subscribe, because if more subscription happens, definitely it motivates us to do more number of videos in the future. So I'm doing slowly. Definitely in future we'll do some more important videos based on some more interesting topics in mathematics. Okay, so thank you all. We'll meet in the next video.